Hey, don't forget to visit weldfever.com store in order to pick up a fantastic looking logo hat or logo sticker. The proceeds help support the show and we appreciate it. Anyhow, on to gate project number 2. So in my haste to get this job done, I forgot to show you guys the welds here, but I went ahead and welded these on, unfortunately, without remembering to film it. So anyhow, here they are. There's the top one, and there's the bottom one. Now, in order to make it up to you all, I've decided to go ahead and simulate the weld by getting a little chunk of steel here that closely approximates what I welded onto the fence, the gate post. And so now, as you can see, I'm tacking it up. Nothing special here, just trying to tack it in the four sides. And I have it up vertically because obviously that's the way I'm going to weld it in the field. Or I should say that's the way I welded it in the field. Okay, coming back into this one here, now that I've got it tacked, I'm going to go ahead and lay a vertical up weld on the side. Keep in mind I'm still using MIG wire and gas. I used that in the field the other day just because it was possible and there wasn't very much wind, so yeah, it worked out. But I caution people against using MIG welding in the field just because of the possibility of wind. Doesn't seem to quite work out well. Okay, so now I'm going to go ahead and get a close-up shot of the next vertical up weld. This is on the other side. I can't really see the molten puddle too well from this way this one was shot, but just pay attention to the side-to-side motion and the slow upward progression. Nice slow and smooth upward progression. That gives you a nice fillet weld in there. Okay, and we got the door up now, and now the only thing I'm looking at here is as we're trying to close it, it was having difficulty closing up. We had to do something over here actually. We had to put a bolt over here on this side. I don't know if you noticed this, we had a bolt that we had to put through the stud because the concrete guy that put this in didn't exactly nail it. So unfortunately this thing was bowing forward. So we had to put a bolt through here and get it into the stud of the wall to keep it plumb. Then once we did that, we noticed that this section here, the latch, the catch here for the door was actually sticking out too much. So I've already ground that down, but also the thickness inside there is too much, and so the actual latch here won't catch onto it. It won't go in all the way. So I'm going to use the old die grinder and go ahead and grind some of that out. Here we go. For those of you who have ever used a die grinder, you know that you really have to steady yourself when you use this tool. You have to hold the tool extremely firmly so that it won't get away from you, because that bit just wants to grab in and just rattle around and go. Okay, you'll notice how much thinner this side is now than this side. This was the original thickness of this side as well, and that's why the latch wasn't catching here. So let's take a look now and see if this thing closes. Perfect. Okay, I've got my welder open, as you can see here. I'm now going to discuss something I don't think I've ever discussed on the show before, and that is the use of flux core. Now, I happen to have this particular brand here, and it goes under the name of NR211. The AWS designation for flux core of the nature that I'm going to be using today is E71T-11. Again, that's E71T-11, which this falls under here. And surprisingly, there it is, in very tiny, tiny small print, they have E71T-11. This is made by a major manufacturer, and their trade name for their particular type of wire that follows that AWS specification is InnerShield NR211-MP. Now the MP is important. That stands for multi-pass. There are flux core wires that are SP, and that would be single pass. And what that basically means is a single pass is all you can use it for. You cannot pile another pass on top of it. If you do, you will have problems and you will not have a good weld. So if you intend to use flux core for something where you're going to do multiple passes, make sure you have a multiple pass wire. So why am I going to use this? Well, in the first part of this series, I actually MIG welded the pieces onto the gate successfully because it was very little wind, if any at all. But usually when you do outdoor work, 9 times out of 10 there's going to be some kind of wind out there, and as you well know, any kind of wind is going to disrupt the gas shielding for MIG welding. I believe, if I'm not mistaken, it's 11 miles per hour or above will totally disrupt your gas shielding. That's not much, and it really doesn't take much to get that gas shielding to just blow away, and then you end up with porosity and a poor weld. So to avoid that problem, the answer or the solution is to use flux core wire. This way we don't have to depend upon a gas shielding in order to cover and protect our weld. Rather, there is flux in the center of a hollow tube wire, which is, and I'll show you right now, this wire right here. And that shielding, that flux in the middle, will actually cover the weld with slag, much like a stick welding process would. And then of course you have to chip the slag and go from there, just like stick welding. So anyhow, I'm going to go ahead and install this wire into the machine, and from here on out we're going to use this, and I'll show you how it goes. Now don't forget, very, very important when you're doing flux core is to change the polarity of your machine. These contacts here determine which polarity you're going to be using. Normally when you're MIG welding, you're going to be using DC positive, which basically means that the gun is going to be connected to the positive cable, the one with the little plus on there, and the ground will be connected to the negative. However, when you weld flux core, you have to remove these nuts and change the wires from one spot to the other to go to DC negative. And so now the actual gun lead will be connected to the negative cable and the ground will be connected to the positive cable. And that is called DC negative or direct current electrode negative or direct current straight polarity. If you don't change these over, the minute you strike up a weld, I guarantee you'll know something's not right. Okay, so we're going to start by cutting off this pole here, first taking a measurement, and now I'm going to go ahead and I'm going to start off using an angle grinder with a cutting disc in it, although I know I'm not going to be able to get all the way with this just because of the way it is. So, but it makes a good straight clean start off cut, so that's why I chose to begin with that. Now we're going to go ahead and finish it off using a reciprocating saw, which is probably the best choice for this. Cuts quickly and cleanly, and sure to go all the way to the end there. Making sure that we get the very last of it here. It's kind of a tricky, dicey situation. Got it. Okay, now what I'm doing is I'm cleaning up the edges. I'm removing the paint from a good little distance from the top to the bottom, simply because we're going to be welding and the heat is going to affect the paint. It's going to cause it to melt and peel up and smoke. And in addition to that, if that paint is not removed, it could contaminate the weld, bubble up and make its way towards the weld. So we definitely want to remove a good portion of it. Okay, so I have this little piece here that I've cut off for a cap. Now normally I like to have a thicker piece of material that's actually going to make it to the ends, and then I like to kind of bevel this down and put the weld in between the two pieces. But this one here poses some interesting problems, and the biggest one being that I can't get to the rear of this because it's against the wall. So what I decided to do is make this much smaller so that I can just put a bead right in the back here and it'll actually overlap everything, and I can do the same around all the circumference of this and build up enough weld material to then be able to shape it and make it look like it was just a natural cap. So that's the plan. Okay. I'm going to start with a few tacks. Okay, now that those tacks are in, and because this is flux core, I'm going to have to clean them off before I can actually do the weld. Okay, so now I'm going to go ahead and start with the actual weld. I'm starting with the edge that is closest to the wall. You can see I have a piece of sheet metal between the wall and the post, and I'm actually going to work my way around, since I'm in the right angle, and nail that other side that's closest to me as well. So now I've chosen to come around and get the complete opposite side. You'll notice that I'm welding kind of partially on the upper edge of the pole, simply because it's so thick. You know, the thickness of the material of this pole is so much so that this little end cap can rest right on top of it. And so I'm really welding more on the thickness of the inner wall of the post rather than the cap itself, and that's how I'm able to pull this one off. Okay, and here's the finished product, and I think maybe now you're able to tell exactly what I was trying to do here. I think I pulled it off. I got a nice rounded effect on the edge. And now I am dressing these edges up so that I can get a nice high polish finish and a nice smooth appearance to this end cap. Okay, and so here's the final result of that post after it's been cleaned up and sanded down. Very nice fit and finish look. The client was very pleased with it. And now here's another shot of the finished post after a little bit of primer. Hey, that's going to do it for this episode. I hope you guys enjoyed it as much as I did. Stay tuned for the next one coming up soon, and visit weldfever.com for the forum, for additional information on welding, and especially for your Weld Fever logo gear. Take care.